Scrap tires are one of the world's most troublesome solid waste problems. Every year, some 300 million pile up in the U.S. alone. Besides their sheer volume, the bulky discards present many problems in local landfills, creating a global challenge. Many end up in giant tire piles. In the U.S., there are more than 2 billion tires piled up around the country, making them one of the most serious solid waste problems ever encountered. The piles are not only an eyesore, they are an environmental nightmare. Dozens of these piles have caught fire, and since each tire contains at least 1 gallon of oil, the fires are almost impossible to extinguish. Some have burned for months, sending massive amounts of black smoke and dangerous particulate matter into the atmosphere, as well as contaminating groundwater. But this dilemma has a happy ending, thanks to the work of Charles McDonald, a former Phoenix City engineer. In the 1960s, he developed a way of blending scrap tire rubber with asphalt to create an improved paving material that is now known as asphalt rubber, and the subject of a standard from the American Society of Testing Materials. 30 years of laboratory and field testing has proven that his way of adding crumb rubber from old tires to conventional asphalt cement produces a pavement that lasts much longer. And that added durability is just one of the benefits of this remarkable paving material. Portland cement concrete pavement is a rigid surface, and conventional asphalt becomes brittle with age and oxidation. But the ground they cover is constantly expanding and contracting with temperature and other element changes. It doesn't take long for this underlying movement to produce cracks in these roadways. If not repaired quickly, the cracks grow to the point where the highway's subsurface is exposed to moisture, triggering more extensive damage. The advantage of asphalt rubber is its ability to provide a firm highway surface while remaining flexible in all climates. It provides a resistance to cracking that can double pavement life while reducing traffic noise and increasing tire traction for better safety. And it puts millions of scrap tires back to work. When you look at the facts, the advantages of asphalt rubber are clear. Just putting an end to the dangerous tire piles and keeping scrap tires out of local landfills would be enough for many. But it's the engineering benefits of this paving material that make the biggest difference. You can produce a smoother roadway with better tire traction and less noise that lasts twice as long as conventional materials. And you only need half as much material to do the job. George Way is an engineer with the Arizona Department of Transportation.
When we first started to use asphalt rubber, it was primarily to address reflective cracking, and that's a form of distress on our pavements. Whether we used up 1 tire or 1,000,000 tires really was not on our mind, and to be quite honest, it still is not necessarily on our mind. We know that using old tires is a good thing for the state of Arizona, but from the DOT perspective, we use them primarily because they perform very well on the pavement. That's the main reason.
That improved performance is also the key to understanding the costs of asphalt rubber. Initially, it can cost more per ton than conventional asphalt, but it's the total project cost that tells the story. On a section of Arizona's Interstate 40 near Flagstaff, at an elevation of about 7,000 feet, a 5-mile section was reconstructed in a conventional manner for a total cost of about $45 per square yard, and it took 2 years to complete. Later, an adjacent 10-mile section of the interstate was overlaid with asphalt rubber in just 4 months for a total of only $10 per square yard. After 9 years, the asphalt rubber section had no cracking. But in 10 years of service, the conventional section was so badly cracked that it had to be overlaid with asphalt rubber. Through experience, highway agencies are learning that asphalt rubber is really the less expensive choice when everything is considered. Independent research has documented that when all the variables are taken into account, it is the best choice in more than 80% of all highway applications. The life cycle cost analysis is a support tool that highway agencies are encouraged to use by the Federal Highway Administration in analyzing alternative pavement design strategies. Such an analysis was conducted on asphalt rubber to qualify the long-term economic implications of initial pavement decisions. The study identified alternative maintenance and rehabilitation strategies and their expected lives, and included all costs incurred by an agency over the life of the project, from preliminary engineering to future maintenance. 3 scenarios used by the California Department of Transportation and their alternatives were examined. With a spray-applied membrane, asphalt rubber produces a savings of $4.11 per yard over conventional asphalt. With a thin hot mix asphalt overlay preservation, the savings for asphalt rubber climbed to $5.18 per yard. With a structural overlay, asphalt rubber saves $7.34 per yard over conventional asphalt.